Hello, Namaste. Myself Chandrakantji. This is my Module 5 assessment on applied statistics, where I am going to take few questions to explain for all of you, where the answers are written by me. And I will go ahead with my first question, that is, what is backpropagation? This is the backpropagation question and answer. Backpropagation is an algorithm used in AI and ML models to train the artificial neural networks through error corrections. Let us go ahead with my Figma dashboard where I can explain you with correctly. Yeah, this is my Figma dashboard. Yeah, this is a screenshot of the answers. Backpropagation is an algorithm used in artificial neural networks through error corrections, where the computer learns by calculating the loss function. What is the loss function? It gives an input and it produces an output, and it see with the expected output and calculated the difference between what is the input it has provided from the customer or the user and output it's producing, where there are two types of backpropagation that are static and recurrent. Static is in a feed-forward neural network where the information flow in only in the unidirectional. It not comes back, especially from input nodes to output nodes. In recurrent backpropagation, where it involves a recurrent neural network that processes the data sequence, unlike the traditional feed-forward network, through the process data in a single direction. Okay, let us go ahead with the correct example. Yeah, where this is a neuron where it first calculate the input which given from the customer or the user, and it pass on the output and produce the output and pass on to the next, where it calculate the what is the expected and what is the difference, and then it will come back, or it will go ahead and once again cross verify it and once again pre-process the data. With the artificial neural networks, though, it keep on doing until the expected output is come. This is an output where we expected from it. This is a backpropagation algorithm. Let us take one good example to understand this. Let us say there is a boy who is trying to put the ball in the goal post. First time he tried, the ball went above the goal post, or second time it not reaches the goal post itself, third time it goes left, fourth time it goes right, like that it was happening. This is static, and we keep on trying and keep on trying. There is a possibility that the ball will go ahead for the goal post. Maybe there is a chances or there is not any chances. So this is an example, good example for static backpropagation. Static. Let us go for with a back current. Okay, here the coach will come. Coach will guide what to do and how to do. Coach tell to his student that he has to put little effort and put the goal or aim to little bit of left, so that the ball will go ahead to the goal post. Where here the coach is acting as the mentor, or is in a loss function. He is reducing the probability or the chances of the ball which will not reach the goal post. He he tell to his student that the ball has to go for little bit of left, so there is a higher chances of the ball will go to the goal post, or there is a less chances the ball will not go to the goal post, or it will not reach near to the goal post. These are the best example for the backpropagation. And let us go for next question. My next question is, what is probability theory and what are the primary components of probability theory? Probability theory. Probability theory is a branch of mathematics that deals with quantifying uncertainties, which means if I toss the coin, it will come head or tail. If I roll the die, it will come 1 or 5 or 3 or 6. It can be anything. It provides a framework for us to understand the concept of probability and what are the possible way the output will come. Like if I toss the coin, it will come head or tail like that. It given a us the value, like what is the probability or what is the likelihood of this event occurring in this random experiment or in this process. This is mainly using AI ML models, and in economics, physics, biology, and especially in engineering, where the probability theory is studied and used there. Next, what are the primary components of probability theory? In the probability theory, there are mm, various of components are associated with it. In that, the few are the primary components of probability theory. First one is experiment, or we also can tell us what is trials. It is in a process of uncertainty outcome. In a process with uncertainty outcome, that means I'm tossing the coin flip. This is an experiment I'm doing, or this is a trial. I don't know what is the output or the result will come, but this I flip the coin. There is an experiment or trial one. If I do 3 times the coin flip, the 3 times is there. 3 trials was done or 3 experiment was done, like that. Second one is sample space. Sample space is a set of possible outcome in the experiment. That means flip I'm coining, what is the head or tail will come. Rolling the die 1, 2, 3, 4, 5, like that. Event. What is meant by event? It is a subset of sample space. It tells us getting the heads. That means I roll the dice. It is what is the probability of getting 4. If I roll the die for, if I roll 2 die, what is the probability, what is the event that the sum of 2 will come to 4 or 5, like that. Next one is probability. It measures how likely an event will occur, like from 0 it's to 1. Example, if I tell 0 has a tail and 1 has a head, what is the probability or what is the likelihood of that event will get a result of heads? That is certainty. Next one is random variable. A variable whose value is determined by the outcome of an experiment. This is a random variable means, in simple words, if I roll the dice or if I playing the cards, what is the random output will come. The output or the outcome of the experiment of the value will assign a variable, that is called random variable. Next one is probability distribution. It is a function that describes the probability of the different value of random variable occurs, or the different values of probability variables. This is a probability distribution. It describes all the probability of different variable will come. Next, conditional probability. Conditional probability means the probability of an event given that the another event is already occurred or it has occurred. Example, my conditional probability is when I flip the coin for the first time on the experiment 1, it's come head. There is a conditional probability, that is this condition is already applied or this result is already came. Next, what is the probability of event next will come? We'll use there we will use conditional probability. Dependency. Two events are independent if one does not affect the probability of other. That means on the first flip, the event on that event or in that event, the sum value is came. On the second also, this first trial is not affecting that. There is an enormous gap and equal opportunity for the two probabilities will come and other probability will come without affecting the probability of previous one or the new one. Next is Bayes theorem. It is a fundamental formula for conditional probability, which we'll talk about later. You can also study in my notes what is the Bayes theorem and everything. And next will come for law of large number. The law of large number is a very useful and most used law in the probability theory. It states that as the number of trial increases, the results it tends to approach the expected value. That means if I took, let us go for my Figma dashboard, I will explain it in short. Yeah, law of large number means if a person flipping a coin, on first he got heads, on second he got tail, third time he got heads, fourth time he got tail, like that. Has his expected value is the more number of heads will come. So he keep on trying, like first heads, then tiles, then heads, like that. If you keep on doing the enormous number of times the trials, one, two, three, four, 5, 6, 7, 8, 9. Here 9 trials was taken or 9 experiments was done. Like that he keep on doing, then what is his expected value, that is head, will come as a majority number. That is the simplest and easy explanation of a law of large number. Let us go ahead with the next question. What is Bayes theorem and how it's used? A Bayes theorem is a probability theory that describes how to update our beliefs about an event based on the new evidence. It provides us to calculate the probability of the hypothesis being true to given some observed data. Before going for the formula, I will give an example how it works. If a patient go to doctor and he tells the symptoms, like this is like I have a cough, I have a cold, I have something fever, like this. Like based on these symptoms, we call it as an event. Based on this many new evidence, doctor will update his belief that he may be have dengue, or he may be have malaria, like that. Based on the symptoms, based on the new evidence, doctor will believe that it may this disease may probably happen for him, like this. Let us go for the formula. P of A bar B, that is equal to P of B bar A into P of A divided by P of B. What is P bar AB? It is a Poster probability. That is what the probability which we require. Probability of B of A. It is the likelihood that this is the likelihood, like B bar of A, like this is a disease. If it is dengue, it has some symptoms. Is the same symptoms or not, like that, into the prior probability that this may be happen, like these are the symptoms. We have this much of symptoms and this much of for the that disease, this much of probability, this much of symptoms, and divided by based on the evidence what is there on the table of the doctor. On that we will get the probability. Let us see what is the use case. Like as I told, first use case is medical diagnosis. Given a patient has symptoms, that is an evidence Bayes theorem can calculate the probability of a specific disease being present. Second one is by analyzing the words and phrases in an email, the Bayes theorem can help us to determine it's a spam or not. We are using day-to-day life our Gmail, Google Gmail account, where based on this Bayes theorem, it will filter out the mail which we receive. Next, this is machine learning. In the machine learning, there are many like tasks like classification, regressions has to be done. In the machine learning, they also use this one. Next is risk assessment. In the financial institutions or in any that type of that institution, it will assessment the risk of the happen or risk estimate they will do about the when the new information they get, what is the risk we are taking and how much the risk we are bearing for this thing, like that. Let us go ahead with our next question. What is the difference between correlation and causation? Correlation is a statistics measure that quantifies the strength and the direction of the relationship between the two variables. It indicates whether how much the variable changes together. The correlation does not imply the causation. It simply describes the degree of association between the variables. The higher the coefficient suggests that the change in variable to tend to accomplish by changing another, but it is not indicating which variable is causing the changes in the other. Next one is causation. The causation is also referred to as a statistics measure. On the other hand, it refers a relationship between the variables where one variable directly influences the change in another variable. It establishes causation require more just an observing our relationship. It involves demonstrating that changes in the one variable is in changes in another variable. If I give an example for causation and for correlation, in causation, if we study hard every day, that's lead to the higher grades in the test. Study hard, it's our daily activity. It's an effort we are putting. Getting the high grades, there's a result that if we study hard, we will get good marks. On the other hand, on the correlation, the ice cream and drowning on the summer is more, where ice cream and drowning don't have a direct relationship between them, but in the hot summer, the price of the ice cream will increases and drowning also increases. Here, the cause is hot weather, but there is no relationship between the correlation. It is a major difference between correlation and causation. Let us go ahead with our next question. What is hypothesis testing in statistics? Hypothesis testing in statistics is a method for evaluating the evidence from a sample to make an informed conclusion about a population. It involves two statements. That is, one is null hypothesis, second one is an alternative hypothesis. In a null hypothesis, we usually assumes there is no effect is happening. In our alternative hypothesis, we are suggesting it will have this amount of effects on this. This is used for data analysis to determine there is how the testing will have, and it will determines if there is enough evidence to reject the null hypothesis and potentially supporting the alternative hypothesis or not. Next question: what is the purpose of null hypothesis in the hypothesis testing? The null hypothesis test is a hypothesis testing in a specific statement about a population parameters that we aim to test for. It will typically represent as a no effect. The null hypothesis typically represent no effect is happening. What are the tests we will do? There is no effect is happening in this scenario. The alternative hypothesis is an opposite of a null hypothesis. Let us see how this null hypothesis will work. It will provide a baseline that the null hypothesis put on a base. This is the starting point of the test. We assume there is nothing will happen. Nothing will happen, and it will help us to focus the test. If we formulate a specific null hypothesis and alternative hypothesis, we are clearly defining our focus on what to make, and it will give a real difference between the groups or the effects. Next one, guide interpretation. The outcome of the hypothesis test usually depends on the p-value and the chosen significant value. P-value, we'll see what does that mean, and it will choose a significant value like chi-square test or other things. It will help us to draw the conclusion about the population parameters in giving the evidence against null hypothesis. Let us go ahead with an example in our Figma dashboard. Let us take an example that a fertilizer company has launched a new fertilizer. It has to launch a new fertilizer that will help the plant to grow. What will be our null hypothesis? Our null hypothesis will be there will be no effect. Alternative hypothesis, null hypothesis, there will be no effect if you put the fertilizer on the plants or not. On the other hand, in an alternative hypothesis state that something will happen or the plant will grow. As you can see here in the picture, has this guy, the guy is pouring the fertilizer for it, and day by day it's growing. This is an alternative hypothesis. What our null hypothesis is that nothing will happen. If the plant will grow. Then our null hypothesis will be rejected and we will select alternative hypothesis and we'll go ahead with it. That's it. Let us go for next question. What is t-test? A t-test is an inference statistics that we use to determine if there is any statistics difference between the mean of two variables. The t-test is used for hypothesis testing in statistics. We will see the example in the later question. Calculating the t-test requires three fundamental things. One is mean value from each dataset, and the second is standard deviation of each group and the number of data values. And t-test can be dependent or independent. Usually for here we use a probability distribution function where we use two type of z-test and t-test. When we have to use t-test and when we have to use z-test, we have to use t-test if the sample or the experiment we are doing is less than 30, then we have to go with t-test, or it is more than 30, then we have to go for z-test. There is only this much of difference between z-test and t-test. Let us see, there are mainly two difference between in this t-test. Let us go ahead with our next question. What is the difference between one-tailed test and two-tailed test? One-tailed test. One-tailed test means it takes assess whether one mean is significant greater than or lesser than another mean. What does that mean by? Let us go with our Figma dashboard and we will understand. Yeah. This is our one-tailed test. Here we assuming the null hypothesis that in the first drawing we will understanding that the mean of the value is less than this much. Less than this much. We are only focusing on this. We are not focusing, it is not greater than like that. On the second, we are focusing that our value, the null hypothesis, that the value or the mean which comes is greater than this much. That is on the first one 0, 5, 10, 15, 20. In the first null hypothesis, in the first one, our null hypothesis is that the mean value which will come is less than 5, not equal to or greater than, only less than 5. On the second one, our focus is that our null hypothesis is greater than 15, only greater than 15. Okay, let us go with a theory explanation. One-tailed test, as I told, it signifies it is greater than or less than another mean. It simply specifies the difference between the mean. The critical region is located either entirely in the one tail of the distribution of the sample mean or in another. Like here, its critical region is only one side. Example, null hypothesis, mean of first one is less than or equal to mean 2. Alternative hypothesis state that the mean one is greater than mean 2. That's it. If the calculated t value fall into a critical region of the tail, then the null hypothesis is rejected in the favor of alternative. That means our critical region is here 5 in first one. If it is go behind, above on that, then we will reject the null hypothesis in the favor of alternative hypothesis. Let us go with two-tailed test. Two-tailed test is same that a two-tailed test, it evaluates whether there is significant difference between the mean of two groups or condition. Here, null hypothesis states that there is no difference between the mean itself. Let us go for our example chart. Here, it is stating that from 0, 5, 10, 15, 10. Here our null hypothesis is that it will come between 5 to 15, the mean of the mean of the value will lies between 15 to 5 or 5 to 15 itself of the mean 1 and mean 2. Here it is taking the both the sides. That's why we call two-tailed test, where the critical region of the t-value would lead to rejecting null hypothesis in split into two parts on the either side of it. This test is used if the means are different from each other's, regardless of the directions of the difference, where our null hypothesis is mu1 is equal to mu2. Alternative hypothesis for mu1 is not equal to mu2. Let us go ahead with our last question. How is hypothesis testing utilized in A/B testing for marketing campaigns? Hypothesis testing, it plays a crucial role in A/B testing for marketing campaigns by providing a statistics sound way to determine the observed difference in performance between variation A, variation B due to changes of real effects. Let us see one by one. Step 1. We will formulate the hypothesis. First, the hypothesis, there is no difference between the variation. Second one is alternative hypothesis, there is a difference between A and B. Next, we will choose the matrix and correct the data. We will define a key performance indicator, like if the customer click this one, or if we see this many of seconds, like this, we will define a key performance indicator, and we will split our audience to two types, A and B. After that, we will conduct a statistics test. To choose a statistics test, we will see the data and we will select the appropriate test we have to done on that. Example, chi-square test. Then we will calculate the p-value. By observing the result by chances, we can interpret if the low p-value it becomes, then we have to reject null hypothesis. If the high p-value comes, we can't reject null hypothesis. Next, based on the results which comes, we will make a decision. If we have to go with a variation A, where we have done that, or the results which we have got, or on the B, or we have to explore further, or we have to do some other tests. Like this is not working out, we have to define another key performance indicator, we have to do on that, or we have to assumption we have to change this. Let us see with an example of this one. We have considered an email campaign where the goal is to determine which subject line is more attention grabbing. Let me give a personal example of this. The Tata Brew, which is something similar to the Twitter or X, they will every day send an email. This is a newsletter, we call it as. It create a stunning email subject where it creates for me astounding or fascinating to read the entire data. If it is someday the subject was not pretty attractive, then I'm less likely to open that newsletter. Let's go with another example. Two different subject lines are created here. Let us like the example I given. Let us say A, that gives get amazing discount now, and B is new product you love. We will send these two to the variation A and variation B, and we will see half of the email list receives variation A and other half receives variation B, as we told. After some days or some while, we will perform a chi-square test. Can be used to see this is for this, and if there is a significant difference in opening rate between the two subject lines, then we will reject the null hypothesis because the low p-value it will come. So it makes a really difference on subject lines, which I told with my personal experience, and the winning subjects wins, and we will choose that one for the rest of the email campaign. This is the same example which I took from my personal. From this, I will conclude my assessment video. Thank you for giving me the opportunity, and thank you.